All right, students, welcome to your second lesson on functions, and we are still carrying on with the parabola that we started, and today we are going to talk about finding the equation of the parabola. And after some time I'm going to show you how these inequalities make it, they get into the way at times of in these functions. So I would like to show you how functions and these inequalities work together towards the end of this video. So let's go ahead and start. In today's lesson, I want you to first of all notice that the quadratic function is given or can be expressed in three ways. So these are the three ways that we've got that the quadratic function or the parabola can be expressed in. This one is the standard form. We talked about it in the previous video where we said if we wanted to find the turning points, we can just say minus b over 2a here. And we remember that c was actually our y-intercept if we have the equation in this form. Well, that was what that equation was good for. Well, we also talked about this one at the beginning where P and Q were the turning points. So it's right here. The turning point will be calculated by saying P and Q. Every other thing you calculate it the same way. If you want the y-intercept, you make x0. If you want the x-intercept, you make y0. Well, this one is the new one that we are seeing for the first time in this video. The one where you actually have x-intercepts in there. Notice there is x1 and x2 written there. Please, they represent the x-intercepts. So in this particular video, we'll be finding the equation of the parabola. The parabola will be given, and then we will have to find the equation thereof. Well, it's difficult to keep talking about math rather than just doing it, so let's go ahead and do it quickly. So let's start with the top number one. The question simply says, determine the equation of the parabola, which is a turning point you heard, at 3 and 4, and it passes through this point, 4 and 2. So because it has a turning point, you will have to use y is equal to ax minus p squared plus q. You use this one because you were given the turning point. So it is very easy to substitute. You just go and substitute in there. In place of p, remember, you just change the sign of the x value. So when you write it in there, it will be x minus 3 squared, but the q value, you write it as it is, so you write it as a 4. So everything has already been calculated. The only unknown we seem to have now is that a that is over there. So to get the unknown, you have to find any other coordinate given that is on this function, and then you substitute it in place of x and y. So luckily for us, we have this coordinate 4 and 2, which was given to us over here. So it is 4 and 2. So we are going to put in place of y, we put a 2, and in place of x, notice how I am going to just put a 4, okay? So we put a 4 in place of x. Everything else will stay exactly the same. So it's now a matter of us calculating this, either using our calculators or our good heads, and then we carry on. So 4 minus 3 should be 1, 1 squared, it should be 1. So we have 1a here. So I'm going to take 4 to the other side and say 2 minus 4, I am going to get negative 2. So at this point, I now have the equation of this function. I can write it as y is equal to negative 2. You see I'm putting it in place of a. And then in place of p, there is 3 there. And in place of q, there is positive 4. So this one can be seen as the equation of this function. If there was nothing else stipulated in the question, that is already the equation of this function. But most of the times, these questions say that you must leave your answer in this form, in standard form most of the times. So you have to be able to move from this from this form, the completed square form, to standard form. So it's not as difficult as when you are completing the square for some of you. It is very simple because all you are expected to do is really to FOIL these two brackets here. So it's x minus 3 times x minus 3 there. So if you FOIL those two brackets, you should be able to get x squared minus 6x plus 9. All right, that's what you're definitely getting. And then there is that plus 4 on the other side. So you simplify it until it looks like how it looks in standard form. I'm letting the negative 2 into the bracket, so you're seeing how this is going to be plus 12x, right? And then notice minus 2 times 9, that would be negative 18, right? So if you say negative 18 plus 4, I should still have negative, pretty sure it should be negative 14 over there. So you can leave it like this now. So if you have it like this, you can easily see that in place of A there is negative 2, in place of B there is 12, and in place of C there is negative 14. So you have managed to determine or to find the equation of this parabola using the fact that it was your turning point that was given to you. But you will notice that it's not only the turning point that you're given most of the times. You may be given the x-intercepts. And if you're given the x-intercept, you go via the x-intercept formula. This formula right here. That is the one that we use if we are given x-intercepts. So how do we know it's x-intercepts? Notice these two here. Do you see that y is 0 on both of them? So what it means is that this one and that one are the x-intercepts of this parabola that is given to us. And then we were given a third coordinate, which is 0 and 12. And because it's 0 here, we can see that it's the y-intercept. So we seem to have a graph that has a y-intercept of 12. Let's just try to sketch it in our heads. Let's see. So there is negative 4 here, and there is 1 somewhere over there, and maybe a 12 is over there. What do you think this graph looks like? I wonder. It should perhaps look something of this sort, you think? It shouldn't turn there. It should perhaps turn afterwards. So let's just do this. So it should look something of this sort. That is the only reasonable shape I can come up with. But it's difficult to really try to draw this shape when you do not have the equation itself. But let's get the equation, okay? So here is how we are going to get the equation of this. If these are your two x-intercepts, this one, this negative 4, and this one, don't forget, when you substitute into the equation y is equal to ax minus x1, x minus x2, just remember that the sign that you have here should just change only. So when you write that negative 4, you write it as positive 4 in this, inside these brackets. I explained that one in your first video. So that one which is 1, you write it as x minus 1. Well, the only thing you need now is that a value, and to get that a value, you just need any other coordinate that you can get, which is on this function. And in this situation, we seem to have 0 and 12, so let's not waste time and just substitute it in there. So you put your 12 in place of y, put 0 in place of x. I'm putting 0 wherever I'm seeing x, and then solve. So at this point, this bracket is 4 times negative 1. That's negative 4a on this side, and then we have 12 on this side. That will leave us with our a value of negative 3. So now we already know that our a is negative 3, so we are substituting it back into that equation. So you go and put negative 3 there, and then this should be what you will have afterwards. So it's x minus 1 here. So all you need to do now is to FOIL some things. So I'm going to let you expand these two brackets here, this one and that. So don't forget, x should multiply that one, and it should also multiply that one. And then on the other hand, this 4 should multiply both of them as well. So don't forget, those things have to happen. I'm not going to show every other step. So it should be x squared, then you get minus x at one point, and you get positive 4x. So eventually you should have plus 3x here. and 4 times negative 1, you get negative 4. As you can see, the equation of this function will now be negative 3x squared minus, I'm going to write that as minus 9x, and minus 3 times minus, so that should be positive 12. So this is the equation that I am getting, that of the function that passes through these 3 given points over here. So very simple if you ask me. But it is important that you do your own, you have to be able to do your own sums yourself. So I made a few for you. You've got these 3 to do on your own. So if you want, you can do them first and then look for the solutions later. So how do we get the equations of these given functions? I decided to give you a sketch so you can easily see what you are given. So pause and work these out, then look at the solutions. Well, now that you're done looking at this or trying them, look at number 1 here. Well, if you look at it, this time around, we were given the turning point. And because we were given the turning point in this situation, it will be easy for us to determine the equation of this function if we go through this formula here. This is the formula we use if we were given the turning point. So go ahead. Like I said, the x value here changes. So this one will be x plus 1 squared, and then you write the q as it is. Perfect. That one is sorted. Now, you need to calculate the a value. You need to calculate the a value, and you need something to substitute. That is where that coordinate comes into play. That coordinate is 0, x is 0 there, and y is 2. So in place of y, you put 2, and in place of x, you put 0. Everything else, keep it the same way. Okay? So now it's a matter of simplifying this. 1 squared should still be 1, so this will be a. 2 minus 6. I'm getting negative 4 for my a value. So as you can see, if I keep on working it out, I should be able to get y now of negative 4, negative 4x plus 1 squared plus 6. And then what you just need to do is to FOIL that one in. So it's negative 4, that's like x squared plus 2x plus 1 when you FOIL that one. Remember, we want to put these equations in that form. This question specifies that you have to put it in that form. So there you are. Don't forget this plus 6, this one over here, right? So this part here is giving us this whole part. Okay. So our y is now going to be negative 4x squared, and that is negative 8x, and that is negative 4 plus 6. I don't want to write negative 4 plus 6, so I'm just going to write the answer for it. So that will be the equation you were supposed to get for this function. So please notice something, something I didn't mention before. Look at the a value for this one. Do you see that it is negative 4 when we change it to this form? Okay, so the equation is in this form now. The a value is at negative 4. At this point, the equation was in this form. A x minus p squared plus q. So the a value is still at negative 4. So please notice when you move from one form to the other, the a value is the one that doesn't change. Even its effect does not change. So the effect of that parameter doesn't change. Even if you come to this form, even if I wanted to express this equation in this form, the a value was going to be the same on all three of them. So please keep that in mind. It will come in handy when we start doing some examination type questions, that the a value here on all three of them, it doesn't change. Just as how you noticed it didn't change when we move the function from there 2 here. Okay, good. So this one, obviously, most of you got it right. At least that's what I hope. So let's go ahead and answer the second one. We may have to make a bit of space for it, right? Let's do it this way. Okay, so here is our question that I wanted you to find the equation of this one here. So let's make it nice and big right there. So what did you see about that function? What is it that you were given? What is it that made you jump a little and say, let me use this method? So I am pretty sure you noticed that this time around you were given the x-intercepts, and whenever you're given the x-intercept, the fastest way of going about it is to go into this formula here, which shows the x-intercepts like this. If you go via this formula, this is where we go, in fact, whenever we are given the x-intercept, so we can substitute them in there. Remember what I said, if it is -4 on the graph, when you put it into the equation, it will be positive. And if it was positive on the equation, when you put it on the graph, it will be negative, just like that. And then here, it will be x minus 2. It's a shift 2 units to the right. If it was x minus 2 squared, but now it's not x minus 2 squared. All right, good. So we have everything, and now we need to substitute a coordinate, and luckily we were given this one. So as you are noticing, they don't have to all the time give us the y-intercept. They can give us any point, and we should be in a position to go and substitute it as well. Wherever there is x, you are noticing that I am putting 3, right? Like this. And wherever there is y, I'm putting -14. So this one, 3 plus 4, that's 7. 7 times 1, so this is still going to be 7, right? And this is -14 this side. And our a is -2, according to what we have here. So since our a is -2 here, we can now go and substitute it back into the equation. So we are saying now our equation looks like this. You see, we go back into that equation there and substitute. So it will be x plus 4 there and x minus 2. If there were no other specifications in this question, we're going to leave the equation at this point because it's already the equation of this. We have already expressed y in terms of x. There was no need to carry on, but because they want it in standard form, you have to go ahead and multiply. So I'm going to say x times x is x squared, x times minus 2 is minus 2x, and 4 times x is 4x. So that will give me 2x together, isn't it? And then 4 times -2 will give me -8. All right, so my function here is now -2x squared minus 4x. It should be plus 16. Okay? So we are just determining the equation. The functions have already been drawn for us. As you can see, we are really managing here. If you want to, you can give us the values of a here, and you will notice that your a is -2, your b is -4, and your c is positive 16. Well, let me see how many of you got this one. I thought it was an interesting one for beginners. So I'm wondering how you did this one. Well, again, you can see that you have your x-intercept. So you didn't waste time. You went and substituted into this equation here. So I'm just going to substitute straight away, please, because you know which one I am talking about at this point. But the problem is after you substitute these two into the x-intercept formula, you will need a full coordinate to substitute here so you can get the a value. It does look like they didn't give you a full coordinate there. You were just told is the y value is 16. The x value, you have to get it. So as you can see, it is the axis of symmetry of that function, And we talked about the excess of symmetry before. We said it cuts right into half. So in this situation, I also mentioned that the turning point happens to be the midpoint. The x value here is exactly in the middle of these two x-intercepts. So the distance from this point to that point, and from here to there, the distance is exactly the same. We say that it's equidistant. So it's the midpoint of those two. So if you want to get the midpoint, you just have to add the 2, -1 plus 7, and then you divide that by 2. So it's as good as you're saying 6 divided by 2. I think you're noticing why that would be 3. So the x-coordinate here is actually 3. So what I'm saying is that now in place of y we can put 16, and in place of x we can put 3, like this. And then this is 16, so it's 4 there for this part, 4, and that's, is that -4? 4 times -4, that will be -16, and let's get our a value of -1 here. That's what I'm getting. Hope you're getting exactly the same as well. Are you getting the same thing for a? I wonder if you're getting the same thing. Okay, let's check it out quickly. All right, I am getting the same, so I hope you got that same one. So what it means is that the equation of this one can be written as negative in place of a, and then you put x plus 1 and x minus 7. So let's just expand this one quickly and see what will happen there. So as you can see, we'll have x squared now, and minus 7x. You know, when I do this, that's -7x, and plus x. So I'm going to just write it as -6x minus 7. So the final answer for this one should be -x squared plus 6x plus 7. Okay? So that is all for determining the equation of the parabola. So I thought in this same lesson, let me just show you some things that we also are expected to know in these things before we jump into examination type of questions. So these inequalities do come in parabolas as well, and they look exactly like this. Look at it. Here is a question that I just picked up, and we have gx, which happens to be the parabola this time around. This is gx, okay? And as you can see, there is yet another graph, which is a straight line this time around, and that is function of x, this one. So there are a few things we can be asked at a situation like this. So say, for example, you want to determine graphically. You're not going to have to solve it. You have to look at the graph and determine some few things. So, for example, here, firstly, you were asked to determine when function of x is greater than 0. Well, function of x happens to be the straight line. So when you are saying something is greater than 0, the function is greater than 0, you want to find the time when the function is above the x-axis. It has to be above the x-axis, okay? So when is function of x, which is the straight line, when is it above the x-axis? So I think you're noticing that it is below the x-axis all the time, but from here onwards, you can see that it will be above the x-axis. So let me just remove the highlighting so I can use colors to show you something. Okay, there's your function, back to being black. So here, this part is the one that is above. Remember, function of x is the straight line, so it carries on in both directions. So this part here is the part that is above the x-axis. And as you can see, it is to the left. It is to the left of this value here. So our root is at -4 and we want to go to the left. Well, I think you know that if we're going to the left of -4, we are talking of numbers that are smaller than -4. So that's how you solve such a question. And you carry on to the next one. When is this function smaller than or equal to 0? Well, again, let me explain what smaller than or equal to 0 means. It means it should be below the x-axis. When is the function below the x-axis? That is what you'll be trying to find out. So let me remove again the highlighting part. That was the original function. We want to figure out when the straight line is below the x-axis. I think you're noticing that the x-axis is over here. That's the x-axis definitely there. So whenever it's below it, which means it's all this time, from here all the way, you can see that all the time, it doesn't matter how far you go this way, it will still be below the x-axis. So from this point here to the right, so we can see that -4 happens to be again the root, but we want to go to the right of -4. So those are the numbers that are greater than -4. But because in the question it was smaller than or equal to, we also have to include the root that we are working with. So that's how you solve these type of equations. And let me go to see quickly where we are talking about function of x being equal to gx. Well, these ones are very simple. This means that you are looking for what we call a point of intersection. When are they intersecting? So we talked about it in passing in the previous video. So when you have something of this sort, just know that it's a point of intersection. When are the two graphs cutting each other? So for you to see properly, again, I am going to remove what I highlighted for the previous video, for the previous question, and then here is this one. When are the two graphs cutting, the straight line and the parabola? It is at that x value and at that x value. What is this x value? That is at x is equal to -4, and also another x value is this one. We can see that it is here at x is equal to 1. So those are the two solutions we have. So because in this situation we were asked to solve this graphically, we didn't have to actually do it by using algebra. But I'm saying it's possible to use algebra. This time around you were supposed to use the graph, and those two are your correct answers. But what if you were not using, or if those values were not there, and if you were not using the graphical method? If you want to find the point of intersection, you can just really equate the two functions. That is minus 2x minus 8. Let's go ahead and do it. We are not answering this question because we just answered. I'm just doing it in a different manner. So the equation was negative 2x. I hope you remember the equation. Negative 2x minus 8. I believe so. Is equal to gx. And gx itself, it must have been negative 2x squared minus 8x. Good. So that's the one. Negative 2x squared minus 8x. Let's confirm from the questions. Perfect. Minus 2x minus 8 minus 2x squared minus 8x. True. Okay, so if you wanted to do it algebraically, you were not asked to do this, by the way, I'm just showing you. So if you wanted to do it using algebra, you were going to just carry on like this. So I'm going to take 2x squared to this side and say negative 2x plus 8x, it's going to be 6x here, and negative 8 is on its own. Then you equate this to 0. Well, as you can see, it is going to be x squared, then now that is plus 3x, and then that is negative 4 is equal to 0. And then to finish it off, you simply have to do it like this. You put your x here, and in this situation, two numbers you multiply to get negative 4. When you add, you get 3, so the bigger number should be positive, like this. Those are the two. And your x is going to be negative 4, or x is equal to 1. You know, we got these answers using the graph, but I was just showing you that it can be done using algebra if needs be. So if you were to use algebra in this question, you were going to get it wrong. Okay, so that is 4 points of intersection. Well, I'm running out of space here. Let me just copy this diagram quickly. Good. Okay, there we go. So we've got this here. We did up to C. So what will we do now at D? Say, for example, you want to find when is function of x greater than or equal to gx? Well, what this means is that when is function of x above gx? It should be above. The one that is greater than, it should be above. Okay, and this one is the one that is below. So you want to find the time when this function, the straight line, is above the parabola. So as you can see, if I look at this point, I just thought I should look at this one here. Look at it. The straight line is below. The parabola is actually on top. So we don't want that part. So what do we need? We need a part when the straight line is above. So if you look at this graph here, if I look at this side, notice if I carry on with a straight line, that time it will be above. And then this one here, notice it is below. This is the time that we need. So we need that x value over there. So we know that negative 4 is our root, but we just have to know which direction are we going from negative 4. As you can see, we'll be going to the left. We want values that are to the left of negative 4, so we are going to say smaller than negative 4. But because the question is including here, you also have to include your solution. As easy as that. So when is function of x above gx? When x is smaller than negative 4. I do not see anything too difficult. Well, when is function of x now smaller than gx? Which one should be above now? So now I'm seeing that this one is the one that should be above, and this one is the one that should be below. Okay, so let's go and check when is when. So firstly, let's erase. And I am already seeing the part when the parabola is above the straight line. It's very clear. At this point, you know when you have both function of x and gx together in one, so use your points of intersection most of the times. Those are the ones that work. Your roots here, your roots that you normally use will be your points of intersection. These are the ones that you use. If you're talking about places such as this one here, when we talked about, look to your left, when we talked about function of x on its own greater than 0, you were looking at the x-intercepts. Even if you were to say, when is gx greater than 0, you were going to just look at the x-intercepts for those type of questions. And for this type of questions, you look at the point of intersection. Well, you know that your roots are going to be here and there. That's where your roots are. But where? Which direction? And you know what? That just helped me to look at something, right? Do you see that at D here we didn't use that method and we missed one solution? We talked about when function of x is greater, which is above. We talked about this side only. Did you see that there was this side as well, you know, down here? It's a good thing I talked about this method in time. Well, as you can see this side as well. from this x value to the right. It's also a solution for D. So that is x is greater than 1. So greater than or equal to. You can see that the red line will be above this curve here. Well, now let's talk about the second one now that I am talking about. Like I said, if you're working with function of x and gx together like this and no other numbers, you look at the points of intersection. And then you ask yourself, when is it that function of x is below gx, or when is gx above the straight line? And I'm noticing that it is all this time. Gx is above the straight line. So from this x value to that x value. So it means you are in between your roots. So in this situation, you can write it as x is exactly in between our roots, which is -4 and 1. For this particular one, x was not in between. It was on either side of the roots. But here, the answer is exactly in between the roots. And we are not going to include that because this one will just be like smaller than, not equal to, because this one didn't have an equal to sign. Okay, I hope you're grasping these as we go. Well, let's carry on. Look at this. If you look at, we are on E, let's look at F. For F, I am going to need a new one as well. Let me just do that for a second. To be able to answer F here, I needed the space, and we want to find out when gx minus function of x happens to be equal to 8. These type of questions, they become tricky for others. So we are saying the difference between function of x and gx. So we are practically subtracting the y values. So let's just put a few y values that I'm going to choose. Here, normally when they ask you something of this sort, it will be possible to get, say, things like that. What will be the turning point for this function? I hope you still remember that if we want the turning point, we say x is equal to minus b over 2a. Let's calculate it. It will be x is equal to negative, our b this time around is -8. Okay? So it's minus 8 over 2 by a. In this situation, your a is -2. So as you can see, your x value here is likely going to be 8 divided by -4. That should be -2. So here, this x value is -2. And if you substitute it into the function, into the original function, gx, you should get the y value of 8. Let me put these coordinates in. And just for the love of it, for the love of this question, I'm going to also put the coordinate here of -3. Just substitute -3 into the function, and you should be able to get 6 over there. And if you go this same distance this side, you should be at -1, and that should be at 6 as well. Because we are talking about distance, you know what I'm going to do? I'm going to have to put these lines here so you can see what I'm trying to let you see. Okay, so I also want to find these coordinates as well. So for that vertical line at this point, x is -3. So substitute -3 into the straight line equation and see what you're going to get. You should be able to get -2 here. Substitute -2 into the straight line. You definitely will get -4. And if you substitute -1, you get -1, and it is -6. Good. And this coordinate here, the y-intercept is at -8, and this one is 1, If you substitute 1 into any of the two, because that's a point of intersection, isn't it, people? So you substitute it into any function, you should be able to get negative 10. Okay, good. So I needed those values for you to see them, so we can start answering this question. When you are asked something of this sort, we are saying, when is the distance between these two functions equal to 8? Like the distance from the top function minus the bottom function. It means function of x minus gx. So when is that distance equal to 8? So for you to just grasp what I mean, look at this distance from this one to this one. This distance here, how many units if you try to calculate it? So because it's a vertical distance, you say 6 minus 2. This is actually 8. Oh, so we already have one solution. Well, calculate this distance from here to there. 8 minus 4, that is 12 units. Definitely not what we want. And look at this distance here from here to there, and 6 and negative 6, so you'll get 12 again. That's good. And then this distance from here to here, the vertical distance from 0 to negative 8, you're seeing that it is 8. So we did it this way because it's your first sum that we are doing this. You will see that with all the other sums, I will not have to calculate all these things, all these distance values for me to be able to answer this question. After some time, you gain the skill of seeing exactly where the x values that are equal to these are at. So the answers that we need here, when the difference between those two functions is equal to 8, is at this x value here. And we can see that the answer for that is when the answers for f, let me put them down here, it is at x is equal to negative 3. And also at x is equal to 0. So I think you picked that up properly. Well, it's going to be easy now for us to do g, because we have already talked about what we are doing here. When is the difference between these two functions equal to 12? At which x values? Well, you are seeing that it is at this x value here, and where else? And that x value. So it is at x is equal to negative 2, and also x is equal to negative 1. Those are the two. You know what? Let me just tell you something. Again, people, if we were not asked to do this using graphical method, we could have used an algebraic method here. So say, for example, on g, you see g said we should be able to calculate gx minus function of x is equal to 12. Let's just say you were that person and you couldn't see on that one. So you can actually do it this way. Your gx, let's find it. It is negative 2x squared, remember, minus 8x. Okay, then you say minus, your function of x happens to be minus 2x plus minus 8, right? This was your function of x. You can really solve for x here to just confirm if what you did here is correct. So let's just go ahead and do it. Let's do it and see what we will get, whether we will still get these two x values that we have here. So let's go ahead. This is easy to do. Okay, so if you take everything together, you should have negative 2x squared here, and you seem to have minus 6x here, and on the numbers it's 8 minus 12. So we should put negative 4 over there. So as you can see, I can really write this as x squared plus 3x and say minus 4 divided by negative 2 will be positive 2, like this. So from here, it will become very simple to factorize. So when you factorize this one, you will be able to get two numbers that you multiply to get 2, and when you add you get 3. That will be 2 and 1. So your answers that you're getting will be at -2 or x is equal to -1. As you can see, it works all the time. So these are the two answers that we have. So doing it algebraically is also possible, but you don't do it algebraically if the question asked you to do it using the graph. Okay, so that's the drag. That's the drag right there. Okay, we did F and G, so let's wind it up. So let's have the time when we say function of x times gx. Let me create a bit of space here. Okay, so to answer those two, that's h, isn't it? What do we do with these ones? It's actually just a simple procedure, really, that you have to follow. Is greater than or equal to 0. Just think of this. When you're multiplying two things and you're getting something greater than or equal to 0, it means they have the same sign. So it means if this is negative, this should be negative as well. That way you get a positive. And if this is positive, it means this one is positive as well. That way you can get a positive. Only a positive value is greater than 0. So what we need to do is to find the x values when function of x is negative and also gx is negative. So let me highlight the time when function of x is negative, and that is this whole time. If you say something is negative, you're saying it's below the x-axis. We just have to have one highlighter. Okay, so function of x is negative there. When is gx negative? Let me look for it. It is negative here. And it is also negative this side. I'm just going to highlight that part. When it's negative here, this side, that one, the problem is that one is positive. So I highlighted it in blue. Well, this whole part, what I mean is from -4, all this part, to 0. Look at how this one will be positive. They will have different signs here. So I don't want this part. So what I need is this part. When they are both negative, from this point, you can see that gx is also negative, and even this function here, from here on, it is negative as well. So from 0 onwards, so from 0 going this direction, you can see that gx will be negative, while function of x is also already negative. So we want this part. We really just want this part here. So I'm going to write that one only. It is x is greater than or equal to 0. They are not exactly very easy to understand, but I hope you are seeing it when both of them are negative. Okay, there is also a time when both of them will be positive. So let's look if there is such a time when both graphs are positive. Let's try to look for it. Well, firstly, let's establish when is function of x positive. That is over there. That is the only time it's positive. But unfortunately, when it's positive, gx happens to be negative. So that means we don't have a situation when they are both positive. So this becomes our only solution for h. Well, as for I, it's really the same question. It's the same question. You do it exactly the same way, except this time when you write this solution here, you just don't put the equal sign. You just don't include it. Okay? And then now, when you're at j, it's function of x times gx happens to be smaller than or equal to 0. Okay, so what it means is that if this is positive, this should be negative, and if this is negative, this should be positive. So you want a situation when they have different signs, not the same sign. So those x values, when function of x is positive, let's find them. Oh, luckily for me, it's already highlighted, this part. Function of x is positive. Where is gx in that time? As you can see, gx is negative. Do you see that we just satisfied our condition? For these x values, from -4 going to the left, function of x is positive while gx is below the x-axis, which means it's negative. So we got our solution for this. It's x is greater than, to the left of -4, it means x is smaller than or equal to -4. Let's find out if we have a situation when this is satisfied. Well, when is function of x smaller than 0? Let's remove what we highlighted before so we don't confuse ourselves. When is function of x smaller than 0? It's this whole part. What we need is the time when gx is doing the opposite. So when function of x is below the x-axis, gx must be above. So is that what is happening now? As you can see from this x value, this one is also above. Function of x is below the x-axis, gx is above, and up to that point. Otherwise, it will be joining it down. So all this time, where I highlighted red, gx, it's now green, all this time, gx happens to be positive. So from the x value of -4 to the x value of 0, function of g of x is positive, while function of x is negative at that time. So those are the two x values that we are looking for. We stop right there. So we know that our solution is going to be in between -4 and 0. Our solution is right in the middle of those two. So we are going to include our roots because the question asked for us to include. What do we need here? For a function of x to be negative while this one is positive, we managed to get this solution right here. So this is also a solution, and also that one is a solution for j. Not a very easy skill to have, but I hope you're getting something out of this. Well, and then this one is exactly the same question. Function of x, gx, multiplied by gx, is smaller than 0. It's just not including, so it will be exactly the same as the one that we did up there, except your solution will just not include the -4 and the 0, and also it won't include like this. So this will be the solution for this one. It's exactly the same as that. All right, that is all I wanted to share with you in this lesson. So I hope you learned something, especially this last part. Most people struggle with it. So go ahead and try to build this skill. Let me go ahead now and show you some examination type questions in these parabolas. So you're going to also do the hyperbola and the exponential in no time at all. Thank you.